Morning, everyone. A pleasure to be here with you all in the audience online, but also with this fantastic group of panelists. I'm sure if you read any of these reports about the most important issues of our times, you will certainly find the issues that we are discussing here today. Some reports will say governance of artificial intelligence is one of the most important issues we need to deal with. Certainly, climate change, many of these reports will say is one of the most important policy issues we have in front of us, as well as is one of the most threatening risks for humanity. Energy resources and scarce resources and water is probably another of those issues that you'll see in different reports here and there. The challenge for this gentleman and lady here is how to combine all those things together, right? And of course, with you, I hope we are going to have a very interesting conversation about that. So I don't want to use a cliche here, but voila. Artificial intelligence offers, maybe needless to say, interesting opportunities for addressing some of these environmental risks. And we can speak about that, how the models can help us, and us is the climate scientists, is the policymakers, is the civil society, to solve this very complex equation on how we solve the planetary crisis that we are in the middle of. But tragically or ironically, the same technology that can help us to address the issue is contributing to the problem because it consumes a lot of energy and water and so on. So, again, as I said, it's a cliche, but our job is how we can foster the opportunity and mitigate the risk. And as usual in these very complex lives we have right now, it's easy to say, but not necessarily easy to do. The good news is that these people in this panel and online, they do have some interesting solutions to propose to you, and some of them are already implementing it. So since I'm optimistic by nature, when my team asked me to moderate and I saw what they prepared, I was very happy that it was not only dark and terrible, but it was also about how we can actually walk the talk, right? So the session is a lot about this, to have a dialogue with this group of different actors here that are dedicated to think about this problem and how we can suggest and underline in the 1 hour we have some of these issues. Of course, let's look into the implications of AI technologies for these problems. We will try to showcase some tools and frameworks. UNESCO, with the University College of London, we're going to launch very soon a very exciting issue brief called Smarter, Smaller, Stronger, Resource-Efficient Generative AI and the Future of Digital Transformation, that my dear colleague Leona, who is online, unfortunately she couldn't be here today, also to reduce UNESCO's carbon footprint of people traveling all over the world. But she is the person in charge of this report, and you can ask further questions and interact with her on that. And also, again, as I said, try to highlight the different approaches that we can take to address these issues. So I'm sure we are going to have an exciting panel. And since we need to be expeditive, I will stop here and go straight to my panelists. Let me start with you, Mario. So Mario Nobili is the Director General of the Agents for Digital Italy, AGID, I guess I say like that.
Correct.
And Mario, let's first start on what you are already doing at the strategic level, right? So how your agency is trying to cope with these not easy challenges. Buongiorno, over to you.
Buongiorno, thank you, and good morning to all. Our Italian strategy rests on 4 pillars. Education, first of all, scientific research, public administration, and enterprises. And these efforts aim to bridge the divide, ensuring inclusive growth and empowering individuals to thrive in an AI-driven economy. For the first, scientific research, our goal is promoting research and development of advanced AI technologies. You before mentioned technology evolves really faster. So now we are dealing with agentic AI. We started with large language models, then large multimodal models. Now there is a new frontier about small models for vertical domains. So we met also with Confindustria, which is the enterprises organization in Italy, and we are trying application about manufacturing, health, tourism, transportation. And this is important for energy-consuming models. For public administration, we are trying to improve the efficiency and effectiveness of public services. For companies, Italy is the 7th country in the world for export. So we must find a way to get to the application layer and to find concrete solutions for our enterprises. And education, first of all. I always say that now the debate is not humans versus machines. Now the debate is about who understand, use, manage AI versus who don't. Okay. And in Italy, the AI strategy is, we wrote it in 2024. We have also a strategic planning, the 3-year plan for IT in public administration, and we emphasize the importance of boosting digital transition using AI in an ethical and inclusive way. This is important for us. We have 3 minutes, so I go to the conclusion, and we are stressing our universities about techniques like incremental and federated learning to reduce model size and computational resource demands. This is the first goal. And so this approach minimizes energy consumption, and we are creating the conditions to transition from brute force models, large and energy consuming, to vertical and agile foundation models with specific purposes: health, transportation, tourism, manufacturing. This is the point. Now, I was saying technology evolves faster than a strategy. So we have a strategy, but we are dealing with agentic AI, which is another frontier.
Thank you very much, Mario, and I'm glad to hear the conclusion in terms of what you are working with your universities, because I mean, I'm just the international bureaucrat here, right? I don't understand anything about these things. But I did read the report that my team prepared, and they were making recommendations towards what you were saying. And one of my questions to them, is this really possible? Is this really happening? So I'm glad to hear this, because this is very important. And I also liked when you started talking with how you are interacting with these different stakeholder groups, because we always talk about multi-stakeholderism, but we need to show how concrete it is, right? So thank you very much.
Thank you.
Marco Zanaro, next, Edge AI expert at the Abdus Salam International Center of Theoretical Physics. He also works for UNESCO. My children, they always tell me, why you don't do these kind of interesting things, because they don't understand what I do, right? Because maybe not even I, but people like Marco as the ones walking the talk in UNESCO. So Marco, you have worked extensively on 10ml and energy efficient AI applications, also in African contexts. So can you tell us, and especially for a person like me that is no political scientist, we don't understand anything, so how you can understand the benefits of what you are doing?
Sure, definitely. Thank you very much. So let me introduce TinyML first. So TinyML is about running machine learning models on really tiny devices, on really small devices. And when I say small, I say really small. So devices that have, few kilobytes of memory, that have really slow processors, but they have two main advantages. The first one is that they're extremely low power. So we're talking about, green AI, these devices consume very little power. And second advantage is that they're extremely low cost. So one of these chips is less than $1, and one full device is about $10. So, that's, of course, very positive. And they allow AI or machine learning to run on the devices without the need of internet connection. So we heard, during IGF that a third of the world is not connected. And if we want to have, data from places that are remote, where there's no internet connection, and we want to use AI or machine learning, that is a really good solution. So you ask about application. And so in 2020, together with colleagues from Harvard University and Columbia University, we created a network of people working on TinyML with a special focus on the Global South. Now we have more than 60 universities in 32 different countries. So we have many researchers working on TinyML in different environments. And they worked on very diverse applications. So just to cite few, there's colleagues in Zimbabwe that worked on TinyML for foot and mouth disease in cows. So, sticking this device in the mouth of the cow and detecting the disease. There's colleagues in Kenya working on counting the number of bees that you have in a beehive. There's colleagues in Peru that use TinyML to detect anemia through the eyes in remote villages. We have colleagues in Argentina that use TinyML on turtles to understand how they behave. So very diverse application. Many of them have impact on SDGs. And again, using low cost and extremely low power devices.
Thank you. This is fascinating. As you said, we are having in this IGF, which I think is a good thing, lots of discussions regarding, in this UN language, how we do these things leaving no one behind. Mm-hmm. And these are very concrete examples, right? Sure. Because it's about the cost, it's about being low intensive on energy. So very glad to hear that, and again, to see that those things are possible. And this offers us a bit of hope, because as I said in the beginning, I'm always concerned that we are only looking to the side of the problems and the terrible risks, but without looking into what is already happening to address the issues, right? So let me move now to have a different setting to our online guests. We have one speaker that is speaking from the internet space, from the digital world, and he is Adham Abdzaid, and he's managing director and partner at the Boston Consulting Group. Welcome, Adam, to this conversation. And I know that the BCG, the Boston Consulting Group, is very much concerned about these issues as well. You are putting a lot of effort on that. And you yourself have worked in the intersection of AI, climate resilience, and digital innovation. With a specific focus on the open source AI solutions. So how you can tell us in your 3 minutes the connection of these issues with the main topic of this panel, that of course is the relationship with sustainability, environmental sustainability. Welcome, and over to you.
Thank you very much. Honored and very happy to join this very interesting panel. And I must say, I enjoyed so much the interventions of the panelists before me. I think you asked a very interesting question. I will start my answer by basically the results of a study that has been recently made by Harvard University, which is around the value of the open source wealth that exists on the ground today. The study basically estimates that if we would recreate only one time the wealth of open source intellectual property that is available today on the internet, it would cost us $4 billion. But it does not stop there, because if you assume or if you imagine that this material was not open source and that every player who would want to use it would either recreate it or pay a license, then basically you would increase this $4 billion of cost to $8 trillion just because of the repetition. So in a sense, having something that is open source optimizes significantly the amount of work that is required to get the value out of these AI algorithms or digital technologies in a larger sense. So instead of doing the thing one time, you will have communities that are actually contributing and building on top of the I would say intellectual creation of each other. First, I mean, to be able to get to broader impact at a much lower cost and a much lower energy cost as well. Now, from experience also, and building specifically on what Mario is saying, for you to be able to implement vertically focused AI models that generate value across a certain system or a certain value chain, you need to have some kind of system level cooperation, which means that today, all of the I would say AI breakthroughs that we have been seeing basically through very large generic foundational models, it's there because they were trained on the data that is available out there on the internet, the wealth of text, the wealth of images, the wealth of videos. And basically, these models are good at this generic, generative tasks because of what these models have been able to see and train on. But now, for you to be able to have a meaningful impact with models that have a vertical focus and can create value across a certain system, they have to basically see and train on data and build on top of decisions that are made across a value chain. Let me give a concrete example that relates to this, basically your starting speech. Let's take the energy sector today. If you want to have, or if you're seeking to have basically an AI development that rather than creating a burden on the energy system, actually it's becoming more optimized, then you also need to allow AI to create value within the energy sector. Basically help optimize the decisions from the generation to the transmission to the actual usage. And if I take this energy system as an example, basically currently in very few countries in the world, you can see basically cooperation, data exchange, IP exchange across the different steps of the value chain. This would be essential, and if it is allowed through policies, through protocols, like when we first started the internet with TCP/IP, then the vertical models can create much more significant value that would allow, as a big example, the energy sector to optimize its income and will allow the AI algorithms not only to consume less energy by themselves, but also to help the energy sector itself, I would say, optimize its output and become greener.
Thank you. Very interesting. So at the end of the day, we need to move from the lose-lose game to the win-win game, right? And you mentioned some keywords that I'm sure Yona will talk about: optimization, cooperation. So that's a very interesting segue. Let me just make one remark on the open source and the openness, on the open solutions. That is very interesting. We witnessed a concrete global example during the pandemic, right? When the scientists decided to went open, the vaccines were produced in a record time in human history. So here, mutatis mutandis, we need to use the same logic to fix this huge problem. So, Yona, in Tinu, it's correct?
It's Dino.
Okay, sorry about that. So Yona is a postdoctoral researcher in computer vision and machine learning at the Queen Mary University in London. And you work with Raido project, which focuses on reliable and optimized AI, again, the word. So again, can you walk us through the specific use case from the project where you managed to show this connection with the efficiency and so on? Over to you.
Yes, thank you. I'm happy to be here. So, as you said, RIDO stands for Reliable AI and Data Optimization. And what we're trying to do is to be a bit more conscious when we develop AI models on the energy consumptions that their models are going to use. And by the end of the project, we will have developed a platform that we are going to test it against for real-life use cases. We call it pilots, and that they are spanning different domains. This can be robotics, healthcare, smart farming, and critical infrastructure. Today, we will focus in one specific domain, which is the energy grid, and we're working with two companies from Greece. One is an energy company, the National Energy Company, which is called PPC, and the other is like a research center called CERN. So what we want to do with them is to develop an optimized model for day-ahead forecasting of energy demand and supply, particularly in smart homes, so that they have a microgrid. And what we were given was a big time series model that would predict the energy demand of small electronic devices that we have in our house, including, let's say, a light bulb. The problem with this model was that it was a bit big. It was very good in accuracy, but it was quite big, and it would need quite often retraining because, as you know, when we calculate the energy consumption of a device, this is dependent on the seasonality, this is dependent on the different habits that someone can have in a house. And what we did was simply knowledge distillation. We took this model and we used it as a teacher to train a smaller model to produce more or less same results. It was quite close in accuracy, but we reduced the number of parameters to 60%. So we got a much smaller model, we call it the student now, that has more or less the same performance, and we got several benefits from this process. First, we have a smaller model that consumes much smaller energy. Secondly, this model is easier to deploy in small devices, as we discussed before in the panel, right? Which is very critical because then you can democratize the access to AI to a lot of houses, right? Because if you have a small model, you can deploy it much easier. And also, by maintaining the accuracy, we somehow help these companies have a more accurate forecast of the energy demand that they will be around. And in that way, they can consume or they produce energy having this into their mind. So we are happy with this, and we hope that we will help also the rest of the pilots get good models and have good results.
Thank you. Fascinating. And so it's also a bit about evidence-based next steps, either for the companies or for policy making. I remember a few years ago, before the AI times, but already in the open data environment, a Ministry of Energy of a particular country launched a hackathon with open data so that people could help to improve the efficiency of energy consumption and so on. in the public sector. So transparency always sheds light, sometimes in very funny ways. And after they did the hackathon and the people did run the models and so on, they found out that the ministry that consumed more energy in that country was the Ministry of Energy and Environment, which was a big shame for them. But then they actually implemented some very concrete policies to resolve these issues. So that's also interesting. We need to connect these conversations with the conversation of transparency and accountability and so on, right? So Mark, last but not least, Mark Gachara is a senior advisor, global public policy engagements at the Mozilla Foundation. And we are going to get back to the conversation, I guess, of open source, because Mozilla has a long experience on that. This mission of Mozilla that was always a beacon in summer conversations in the internet environment, how you guys are looking into these new challenges now, and particularly the ones we are discussing in this panel. Over to you and welcome.
Thank you so much. Actually, to kind of build upon what you've just shared, which is very important, I would go back to the definition of trustworthy AI. So what has happened, more has been, we think of trustworthy AI in terms of other dimensions, in terms of governance, but we do not think about the transparency in terms of disclosure on the AI life cycle of how much energy is being consumed. So we think about, let me say, human rights, which is very important. We should not harm people. We should think about the socioeconomic impact. But we don't think about how we are harming the environment in that, and it is a bit opaque in that area. So as Mozilla, one of the things that we've been trying to work on since 2023 is to think about the transparency of how much energy are we consuming. So concertedly from last year, we ran a fund, a challenge where we had a number of grantees think about this particular area. We had, for example, an organization from France called Code Carbon. And within this theme of environmental justice, they were thinking about, when I write code, how much energy am I using? Because at the end of the day, fossil fuels are used to generate the energy. So a developer can actually optimize their code. And it's an open source project that's available that people can access when they are building or using Python tools. Then we also have in the US Methane Mapper. What they did is they did airborne hyperspectral images that detect emissions. So we do not rely on maybe a self-assessment or a self-disclosure, but rather we are kind of doing imaging and using AI to kind of detect where are leaks before they harm the environment. These are just examples of practical use cases that are measuring, because in management they have told us if you can't measure it, you can't manage it. Probably you also can't manage the risk. So I think being able to run this kind of action research that can talk to policy eventually, then sheds light to make like environmental justice part of a core definition of how we roll out AI solutions. Thank you.
Thank you. Super interesting. And if I hear you correctly, there are two important issues. There may be a energy efficiency AI by design, right? From the moment you are writing the code, which is an interesting story also from the human rights perspective, to be by design, but also the capacity of having decent risk assessments for these things. So now what's going to happen, we are going to have a second round here, very quickly, ping pong, and then we are going to open to you. So please start thinking about your questions to these fantastic people here. Mario, you are also the regulator, and regulators can use sticks, but they also can use carrots. Yeah. So I guess my question for you is about the carrots.
Thank you. I'll try to connect some dots, and my answer, I have 3 answers for this, but I want to connect. I fully agree with the other panelists, with Adam. The first one is education, and I connect with the answer from Adam. We are writing with public consultation guidelines for AI adoption, AI procurement, and AI development. So think about public administration. In Italy, we have 23,000 public administration. Everyone must adopt. Everyone must do procurement. Some of them must develop. I think ministries like environment and energy, of course, but also the National Institute for Welfare. And what Adam was saying before is also about the interaction between cloud and edge computing. This is important. But we have also other challenges, and I'm thinking about the energy model, about which are the challenges now for a good use of artificial intelligence, data quality, and breaking the silos. These 2 points are really important for us. So the first answer is education, collaboration, sharing, new questions about what can I do with my data and with my data quality. What can I do about the cloud and the edge services I can develop? The second one, and the Agency for Digital Italy is working on it, is the Open Innovation Framework, okay? It's about new applications, not the classic tender about buying something, but the Open Innovation Framework. So I can enable public administration to carry for planned procedures and facilitate the supply and the demand in a new way. The third one is money. So, so the carrot is money. We are using in Italy a big amount of money from the National Recovery and Resilience Plan. We have 69 billion euros for ecological transition and 13 billion euros for business digitalization. Now we are working on a new framework about tax credit for enterprises for a good start of using AI in the small and medium enterprises.
Thank you very much. This is fascinating, and also finishing with the money always gives people some hope. But I wanted to underline the aspect of procurement, because in 99% of the UN member states, the public sector is still the biggest single buyer. So if we can have decent procurement policies, is already a lot, right? So congrats on that. Marco, on your side of the story, with your experience, if you can tell us what are the key enablers for this story, right? So what are the drivers? If someone needs to start looking into that, the policymakers and the scientists, what would you suggest to start looking into it?
Sure. So you said you wanted concrete, suggestions, so I'm going to be very concrete and practical. So the first one is investing in local capacity building in embedded AI. So capacity building has been mentioned many, many times in the last, few days. But I would say the new aspect from my side is to give priority to funding for curricula that is co-developed with global partners. So, not reinventing the wheel, but using existing and open curricula, such as the one that we developed with the TinyML academic network, which is completely open and can be reused. The second one is to promote open, low-cost infrastructure for TinyML deployment. So people need to have these devices in their hands, and very often that's not easy. So, subsidizing the access to these open source TinyML tools and low power hardware would be extremely useful because, of course, this lowers the barriers, the entry barriers, and stimulates local innovation with these, SDG-related challenges. The third one is to integrate TinyML into national digital and innovation strategies. So people, when they design their strategy, please don't forget that you also have this kind of alternative model of really tiny devices running AI. So that's, a component that should be included. Next one is to fund context-aware pilot projects in key development sectors. We heard from Mozilla about, funding kind of pilots and, testing new solution. Well, that's possible for TinyML. Again, we have seen many, many interesting applications. So, funding even more would be extremely useful. And finally, facilitating regional collaboration and knowledge sharing. So we had few activities which were like tailored for specific regions with the idea that, people from the same region have the same issues. And that has been extremely successful. So, supporting this south-to-south collaboration and, focusing on specific regions so that they can use TinyML to solve their, common issues.
Super, very interesting. So co-working in many levels, right, as you said, but also interesting because been participating in several discussions about DPIs, digital public infrastructure, or also public interest infrastructures. And to be honest, I have not been hearing a lot about what you were saying. So I think it's an interesting way also to connect the dots if this can be more and more presented, right, as a potential solution. So Adam, let me get back to you now. I know that from where you are sitting in the Boston Consulting Group, you are also looking into governance models for this issue. So what are key features there of, obviously in 3 minutes, it's always a challenge, but that you can tell us on the governance side of the story?
Yeah, very clear. It is, I think we've been mainly looking at basically how to inspire what is the right governance for a systems level change to basically push forward, accelerate the adoption of open source, data sharing, intellectual wealth sharing across different systems. And I think the most important thing and is to have I would say the right policies and the right sharing protocols across every industry. To be very well designed, well enforced, as you said before, with the carrot and the stick at the same time. It is also very important to make sure that the different players are actually incentivized to adopt. And actually, as Mario was saying also earlier, have the right, I would say, set up the right regulatory reference for them to adopt on their own level, and then afterwards also sharing the outcomes, the insights, the data with others. We have faced so many difficulties in so many sectors while trying to apply AI applications, whether it's generative or whether it's other techniques with facing the current regulation. The cloud is one, basically having the proper data governance, data classification, understanding what is sensitive, what should be on the cloud, what should not be on the cloud, and under which levels or layers of security. Even worse in several countries, and specifically emerging countries that basically do not have hyperscalers or do not have actual physical wealth of data centers implemented locally, and to have actual regulation against the data traveling, their data traveling cross-border, wouldn't even allow I would say the prompts, the queries that would go up to query foundational models or other models that are sitting in the cloud somewhere outside of the country. So regulating this, what type of prompts should travel? It should actually cross the border, which ones shouldn't, and for which you maybe need to go for local alternatives that are more focused and smaller models, maybe less efficient, but you start there until the regulation evolves is something that is very, very important. But I mean, after all, what is really, really important is to have certain rules across the players in a value chain about what they can share, in which format, and what are the, I would say, the rights and responsibilities that go with it as it moves through the value chain, and for them to believe that actually sharing is a win-win situation. It is not the opposite of, I would say, a free market, I would say, competitiveness and keeping your intellectual property and conserving your competitiveness. It actually contributes to it. It gives you a wealth of information on top of which, a layer on top of which you can develop a competitive edge.
Thank you. Very, very interesting. And again, I guess Marco was with me yesterday on another panel about AI, and the issue of standardization and rules appeared a lot, right? So we will need to deal with that rather sooner than later. So, Yona, again, as you noticed, the second round is a lot about lessons learned and insights for the different stakeholders. So in your case, what you would tell to policymakers from the perspective of you are doing in RAIDO? What are key lessons to share with them?
So, as you said, I have more of a technical background, right? So I think that one of the key lessons that I have learned from RAIDO or working as an AI developer is that sustainable AI is not going to emerge by default. We need to incentivize. It needs to be actively supported. And the reason that even when I train a model, I will opt for a bigger model, I will opt for more data, is the way we are actually measuring success, which is measured by accuracy. So if we are measuring everything by accuracy and sometimes we neglect the cost that comes with accuracy, we might consume way more energy than what is actually needed. Like in some cases, a small improvement comes with a huge increase in energy, and we have to be careful with this trade-off. And I think that one of the first steps that we need to do is to actually simply assess how much energy is used in widely used public models. And what I mean is that I will give you a concrete example, right? There is now GPT-4 or there is DeepSeek that they might have 70 billion parameters and they consume massive amounts of electricity during training and during inference. But we don't really know how much energy is used when we put a simple prompt on ChatGPT. We are not aware of this. So I think that we should start by having some transparency in the way we report energy. So by simply developing evaluation standards at prompt level, it will be a great first step because it will will develop awareness and transparency. And after this, we can see what can be done with this. But without having the knowledge of how much energy is actually used, I think we cannot focus on legislation, right?
Super. Of course, I mean, it's very important that because the transparency generates the evidence that is needed, right? Yeah. And it's a good segue for you, yeah, Mark, because the question for you was precisely how the civil society can be even stronger in demanding more transparency and accountability for these companies.
Yeah, so I will answer the question in two parts. I will start with the things that as Mozilla we see are missing. So right now there's a lot of money going into climate or smart agriculture or climate AI solutions, but it's to make them more efficient, more effective, as opposed to how do we mitigate the harms that they are causing, and Yona has just mentioned a little bit about that. So it is important from our end to think about how the solutions we build can prevent. They can also improve transparency, and then they can make also it more visible over the impact on the environment over the work that you're doing. And this could come through policy work, through research, and also strengthening community work, like strengthening community, civil society organizations that are working with communities on the ground. And I'll give an example of somebody that we worked with last year, but this is ongoing. So in Kilifi, Kenya, we have the Center for Justice, Governance and Environmental Action. They are working on climate justice issues, and there's plans in Kenya to build a nuclear reactor somewhere in Kilifi in the sea. And one of the things that this CSO did was to do an ecological mapping of an area in the Indian Ocean. And they used AI to do this. And they have come up with a report, and they are saying that we think that this is ill-advised. And they've given the reasons why it's ill-advised. We should actually be focusing on using renewable energy sources, because Kenya is a net producer of renewable energy. So this is what civil society can do, for example. They are pushing back. It's still work in progress right now, but you can generate evidence to be able to do advocacy. Unfortunately, once the ship has left the dock, for civil society, you are left trying to push back, which is unfortunate. But again, I come back to the three things. How do we use such kind of evidence to advise policy? How can we do action research? And how do we put money into preventive, into making these issues more transparent, so that actually the taxpayers and government can actually quantify the issue in front of them. Thank you.
Thank you. Very interesting. And also the need to do that in an unfortunate shrinking space for the civil society, and with less funds for this accountability and transparency, including for journalism. So now is the time for you. Questions. Leona, also on the online space, do we have questions for the panel? You have two mics here. I know that this setting looks, we are very distant, but we welcome your thoughts and questions. And Leona, from the online, I don't know if you are hearing us. Sorry.
Yes, hi. No questions yet.
So while maybe you guys are getting less shy, can I ask you, Leona, to be on the screen and give us a teaser of 1 minute about the report that we are going to launch soon about these issues?
Yes, hi. Good morning, everyone. Can you hear me?
Yeah. Yes.
Okay, great. Great to see all of the panelists here, and thank you so much for joining. And I think just to also echo UNESCO's work and really our work on being a laboratory of ideas, and also trying to push the envelope on actually being able to define what do we mean by all these sustainable, low resource energy efficient solutions. So we've been doing this research in partnership with the University College of London, where we're doing experiments actually looking at how can we optimize the inference space, right, of AI. So inference is what other colleagues have mentioned, is when we are interacting with these systems. But really what we are uncovering is, and I really love this conversation so far, because most of you have really echoed the need to be more efficient, climate conscious, and looking at AI in a smaller, stronger, smarter way. So here we're looking at energy efficient techniques, such as, optimizing the models, making them smaller with quantization, distillation, all of these technical things. But what we are really seeing here is that these different experiments that we've done actually make the models smaller and also just more efficient and better performing. And what that means, especially for stakeholders working in low resource settings, right, where you have limited access to compute and infrastructure, these types of models are made more accessible to you. And so it's really also part of the answering the question, you know, what type of model, what type of AI do we need for the right type of job, right? So also trying to demystify the talk that, you know, bigger is better. It's not necessarily better, right? So also as we're seeing now in terms of, you know, all these large language models are power hungry and water thirsty. So, you know, here's where we're trying to, you know, merge two things together. So one is very technical research, how we're able to translate that in a policy setting, what it means for policymakers if you're thinking about exactly developing, deploying, procuring AI systems for your use cases. So if we're able to, by presenting evidence, try to move the needle by promoting more eco-conscious AI choices, right, and model usage, then I think that's one very concrete start to actually have this bigger push to look very concretely on what it means to use smaller and smarter AI. And so actually also in the chat, we're going to put here a sign up link. So all of you will be notified when we launch this report. Thank you.
Thank you, Leona, for the teaser, and I strongly recommend you'll see the report. By the way, is also beautifully designed by one of our colleagues that is an expert in designing. So it try to shows also through cartoons, etc., in a user-friendly way some of these issues that are sometimes complex to understand. Questions from here? Otherwise, I have print. Jan, please take a mic.
Hello, my name is Jan Dublinski. I work for DW Academy in media development under the roof of Deutsche Welle. But I'm also a former, in my earlier life, I was a science journalist. That's 10 years ago. And I'm used to hearing new things. And I must say, I'm thinking while I talk, because most of what you told us is new to me. So that's really exciting. And congratulations for the report and putting together the panel the way you have done. And I'm trying to remember other technological revolutions we've seen in the past and how they could be made more transparent. Like, I don't know, heating systems in houses. You know, in Germany we have passes for every house where you can see how energy efficient a house is, and it's obligatory in the EU, I think. And I think we can think of many other technologies where we made, step by step, made it more transparent to then actually see what it means so people take conscious decisions. And that's why I'm really glad, Guillaume, that you stressed the transparency issue. But of course, next thought I have is we also trade carbon as a negative good, right? So we force the industry to become more efficient by giving them certificates on their carbon emissions. And I wonder, by everything you know now so far about this topic, do you think we can take transparency on energy consumption by AI this far that we can one day actually trade the right to consume energy on behalf of with AI technologies, and by that way force the industry to develop more small models and be really conscious of whether, as you say, we really need to take the last step that will be very expensive to get the very extreme accuracy that we might not need. So, in a way to advance in the direction that you all point to. Maybe our colleague from Boston Consulting Group has ideas on this as he's looking at the overarching strategies. Thank you.
Thank you, Jan. So we have 5 minutes and 39 seconds. So it's 1 minute per person to interact with Jan's question, and I'll maybe already offer us one takeaway. And maybe if you don't necessarily want to interact with Jan's questions, I would ask you something related to what he said. What are the questions you think science journalists should be asking about this issue? So, Mari, over to you.
Well, in 1 minute is very tricky, but I'll try. I think that the key words are related. So we have sustainability, calls for transparency, calls for awareness, calls for policies, also government policies. And I think that the good question is not when, but now we must think about sustainability, energy consumption, and the AI potential, the potential for AI to displace jobs. Everything is related. We cannot think about energy consumption without job losses. Okay, so I think that the journalist can ask for a solution to job losses, energy consumption, awareness from people. It's very complicated. We need 2 hours and not 1 minute.
Thank you, but interesting. And well, that's the job of the journalists to find the time to do it. Marco.
Well, my kind of question would be, what kind of models do we need? So in TinyML, of course, in these small devices, you can only have like models which are very specific to an application. Again, you know, coffee leaves or, you know, turtles. So my point is, do we always need these super wide models that can answer every question we have? Or is it better to focus on models that solve specific issues which are useful for, you know, SDGs or for humanity in general?
Small is beautiful, right?
Yeah.
There was an article in the New Yorker a few years ago. Fantastic. I recommend, not about this, about overall small is beautiful. Adam, your 1 minute.
Yeah, I think it's very interesting. I would reiterate again on what I'm saying. I think yes, smaller, focused models is something that would create significant value and would be much more optimized. To get there, they need to have access to data that is currently not necessarily out there. And for this to happen, we need to have in place the policy, the governance that would make this happen. Because there isn't a wealth of data out there that would allow this. And honestly, to consume the energy that is required for AI to deliver real value within the systems and value chains that helps develop on the SDGs and help the daily lives is a much more important, I would say, use than consuming this energy for the large models to create videos and images on the internet.
Thank you. Yona?
I think that my question will be, as a researcher, if we focus so much on having smaller models, if we actually neglect all the progress that has been done so far with the large language models, all the revolution that has done so far. But then I guess the answer to this is that task-specific small models have still a great value. And I'm talking about actual value. You see our mobile phones, the technology there is small models because they are bounded from the battery life and the processor that the phone has. We can see that our phones are actually having small task-specific models, meaning that there is still a lot of things to learn, except for the energy part, in terms of science and knowledge and the things that we can achieve as humans from pushing the boundaries of research. So I also think that we should give another type of value on this, which is actually the knowledge and the learning out of this process.
Thank you. Mark?
Yeah, on my end, to respond a bit to the question that was asked, the theater of where the most impact of climate is in the global south, and it would be a farmer, it would be indigenous and local communities. So it'd come back and say, like, how do we have funds that support grassroots organizers and indigenous communities to actually build some of these solutions together? It's already been said, like, the problems are really localized and we can focus on local solutions. And then we need to foster funding strategies that could actually look into research and creating science that actually solves these climate solutions with these local communities. And procurement has already been mentioned, which was a good thing, public procurement. Thank you.
Thank you so much. We came to the end of this fascinating discussion. I want to personally thank you a lot, each one of you, because I have learned a lot. I hope it was the same with the audience and those online. Thank you, Adam. Thank you, Leona, for your online participation. And here, Mario and Marco and Yona and Mark, and for all of you to be listening to us attentively. And let's try to make this a greener world while still trying to have the good benefits of this fantastic digital and AI revolution. Thank you so much. Enjoy the rest of the IGF.